Hello everybody, this is Nageswara, Assistant Professor of Physics, Government Degree College, Chintalapudi. In this presentation, I will explain how to get interference pattern in the wedge-shaped film and how can we determine diameter of the thin wire by using this wedge-shaped film. So, as shown in this diagram, there is two plane surfaces GH and G1H1 are make an angle alpha by tied together at one end. If ray AB is incident on the top plate, that is G1H1, which is partially reflected along BR and partially transmitted along BC. This transmitted ray again partially transmitted along CP and again partially reflected along CD. This internal reflected ray CD also again partially transmitted and again partially reflected. This partially reflected ray is passes along the direction of DR1, where BR and DR1 two rays are came from the same source and travel different distances. So there may be chance to get interference pattern. So there I will draw normal to the G1H1 and a normal to the GH at point C and point M to derive the relation for the path difference of these two reflected rays. The thickness of the air between two glass plates GH and G1H1 increases from 0 to highest value, maybe it is T at dm. The refractive index of the film between GH and G1H1 is taken as mu. It is observed that DBR and DR1 are not parallel, even though we have to suppose that those two rays are concentrated from the source S. So these two rays travel different distances and came from the same virtual source S, can form interference pattern. So the path difference between these two reflected rays, that is BR and DR1, can be written as delta is equal to mu into BC plus CD, that is inside of the glass plates, minus BF, that is the distance of the first ray. But we know BC can be written as BE plus EC in the inside of the diagram, and BF can be written as mu BE by taking the triangle BFD. Sin I is equal to opposite by hypotenuse, that is BF by BD. That is BF is equal to BD sin I. But we know according to the Snell's law, sin I is equal to mu sin R. And from the above diagram, sin R is equal to BE by BD. So that from this BF is equal to mu BE. When we substitute this value into this area, so the path difference delta is equal to mu into PE plus BC plus CD minus BE. So when we have to take common as mu in this, where VE and BE are cancel each other, so that path difference delta is equal to mu into BC plus CD. So, but we know CD is equal to CP from the triangle PCB. CP is equal to CD. From this, delta is equal to mu into EP. But from the triangle PCD, we can say that there is alpha plus alpha is here. Alpha is the angle between two glass plates. Then class alpha r plus alpha is equal to adjacent by hypotenuse, that is EP by dP. That is EP is equal to dP cos r plus alpha. But we know dP is equal to 2 dm because dm is equal to Pm. That is path difference delta is equal to mu into 2 dm cos r plus alpha. But we know dm is the thickness of the air film at this place. If it is taken as a small d, then the path difference delta is equal to 2 mu t cos r plus alpha. Actually, this is the path difference between two reflected rays, that is Br and Dr1. But we know according to the Stokes, an additional path difference lambda by 2 is introduced because it is reflected at the denser medium at point B. There is no reflection at the denser medium at point C because there is a rarer medium. There is only one reflection at the denser medium. So an additional path difference lambda by 2 is introduced. So the total path difference delta is equal to 2 mu t cos r plus alpha plus lambda by 2. Of course, it is plus or minus lambda by 2. So we know for the constructive interference, the path difference delta is equal to n lambda. For this, 2 mu t cos r plus alpha plus or minus lambda by 2 is equal to n lambda. If this is lambda by 2, when came this side, delta is equal to 2 mu t cos r plus alpha is equal to 2n plus 1 into lambda by 2. This is the condition of a bright fringe at the wedge shape. We know for the destructive interference, the path difference is 2n plus 1 into lambda by 2. So that the path difference for the destructive interference delta is equal to 2 mu t cos r plus alpha plus or minus lambda by 2 is equal to 2n plus 1 into lambda by 2, where lambda by 2 cancel each other. So that for the destructive interference, path difference delta is equal to 2 mu t cos r plus alpha is equal to n lambda. So this is the condition for destructive interference, where n is equal to 0, 1, 2, 3, 4 and so on. So now how can we determine the diameter of the wire, or of course angle of the wedge? So as discussed earlier, there is two glass plates, that is A1 and B1. This is A1 and this was the glass plate. B1 is another glass plate is tied on end, that is at AB. So there is an angle alpha at one end and the air film increases from A to A1. So there is a thin wire is kept one end, that is at A1 B1. So it makes an wedge shaped film. Of course, it may be air between two glass plates. At this case, the refractive index mu is equal to 1. Due to this, there is bright and dark straight lines we can observe due to the incident of the monochromatic light. So S is a monochromatic source in which a light is incident on the glass plate G, which is making an angle 45 degrees to the incident ray. It is partially reflected along the A1B1 and is reflected at A1B1 surface and another reflected at the ABA1 surface. So that these two rays reflected back and interfere each other, and we can observe bright and dark fringes by using the micrometer eyepiece, where AB and CD and EF are bright and dark fringes alternatively. Of course, where P is the nth dark fringe and Q is the n plus first dark fringe, let us assume. Now, what is the path difference between those two rays? That is the analysis of the above diagram. Now, the path difference between those two rays can be written as delta is equal to, we know actually the formula is for the normal incidence, that is R is equal to 0. And it is air. We have to the air film between two glass plates A1 B1 and B1 and A1, so that refractance mu is equal to 1 for the air. So that according to the path reference 2 mu t cos r, that is r is equal to 0, that is cos r is equal to 1, that is 2t is equal to n lambda for the dark fringe, nth dark fringe. Of course, for the n plus first dark fringe, that is 2t2 is equal to n plus 1 and lambda, where t1 is the thickness of the air at a p dark fringe, that is nth dark fringe. T2 is the thickness of the air at the n plus first, that is at a q dark fringe. Then from these two equations, T2 minus T1 is equal to n lambda. So this is lambda by 2. From these two equations, T2 minus T1 is equal to lambda by 2. But from this above diagram, that is tan alpha is equal to T1 by AP, because we know tan theta is equal to opposite by adjacent. Opposite is nothing but this is the thickness of the air film at P, that is the T1, by AP is the adjacent, that is at the glass plate. Of course, that is the same as alpha to the second dark fringe also, that is tan alpha is equal to T2, that is thickness at the Q, by opposite adjacent AQ, that is tan alpha is equal to alpha T1 by AP, that is equal to T2 by AP. So from this diagram, we can say samely written as tan alpha is equal to T2 minus T1 by AQ minus AP, because of course this diagram we can write for this small area. These are the two rays, P, this is Q, this is the actually glass plate. If it is alpha, we know this is equal to T2 minus T1. So that is tan alpha is equal to opposite, that is T2 minus T1 by adjacent, that is equal to, if it is AQ minus AP, that is tan alpha is equal to T2 minus T1 by AQ minus AP. But we know AQ minus AP is the distance between two consecutive dark fringes. Of course, that is called fringe width beta. So that from that tan alpha is equal to T2 minus T1 by beta. Tan alpha is equal to T2 minus T1 by beta. And we know T2 minus T1 is equal to lambda by 2 in the previous slide. From this, that is tan alpha is equal to lambda by 2 beta. This is one equation we require to determine the diameter of the wire or maybe angle of the wedge. And beta can be evaluated. Beta is but fringe width can be evaluated by cross wire of the micrometer is adjusted at the nth dark fringe, and we have to take micrometer reading. And second is concentrated at the qth dark ring and maybe bright ring also. Then the difference between two readings is equal to fringe width beta. So beta can be evaluated by using the micrometer eyepiece. If D is the diameter of the wire and A1, that is the length of the glass plate, is x, from this diagram tan alpha is equal to opposite D by x. So that is tan alpha is equal to D by x. So this is tan alpha is equal to D by x, and previous slide, that is tan alpha is equal to lambda by 2 beta. When equating those two equations, lambda by 2 beta is equal to D by x. From this, diameter of the wire D is equal to lambda into x by 2 beta. When we substitute wavelength of light lambda, that is yellow, maybe sodium light, x is the length of the glass plate, beta is the fringe width, it can be measured by micrometer eyepiece. Then we can calculate the diameter of the wire using this above formula. Thank you.